Good day everyone, this is Rojan M. Pajota, a second-year EC student in University of Southern Mindanao. Today, I will be teaching you how to solve a non-exact DE using integrating factor. After this, please leave a comment or any recommendations about my video. Now let's proceed to the first example. Always remember that in solving non-exact DE using integrating factor is, remember this formula. 1 over m times the partial derivative of m over dy minus partial derivative of n over dx is equal to f of y. Then our integrating factor will be e raised to negative integration of f of y. 1 over n multiplied to partial derivative of m over dy minus partial derivative of n over dx is equal to f of x. Then our integrating factor will be e raised to integration of f of x. To understand furthermore, let us proceed to the first example. X squared plus y squared plus 1 dx plus x times x minus 2y dy equals to 0. Let us distribute this variable first to the equation. X squared plus y squared plus 1 dx plus x squared minus 2xy dy. Then get the partial derivative of m and the partial derivative of n. This will be my is equal to 0 plus 2y plus 0. Our nx is equal to 2x minus 2y. Then as what we can see, our my is not equal to our nx. Then let us use the integrating factor formula. Let us use first the 1 over n. And this will be 2y minus 2x plus 2y is equal to f of x. You can use trial and error here to find the f of x. 1 over n, 2y plus 2y will be 4y minus 2x is equal to f of x. To simplify the equation, this will be x minus 2y, factor out negative 2, then this will be x minus 2 plus x minus 2y equal to f of x. Then this will be cancelled. Multiply negative 2 to the 1 over x. This will be negative 2 over x equal to f of x. Then our f of x is negative 2 over x. Always remember that your f of x or f of y must always be a constant or a variable. Then let's proceed to the integrating factor. Equal to e integration of negative 2 over x dx. Then factor out the negative 2, integration of 1 over x dx. Then this will be e negative 2 ln x make negative 2 as an exponent. Then this will be e ln x negative 2. Then this will be cancelled. Our integrating factor is x negative 2. After after getting your integrating factor, distribute the integrating factor to your m and n term. X squared plus y squared plus 1 dx plus x squared minus 2xy dy equals to 0. X squared, x negative 2 multiplied to x squared is 1 plus x raised to negative 2y squared plus x negative 2 dx plus 1 minus 2 x negative 1 y dy equals to 0. After distributing your integrating factor, we can now test if the equation is already an exact differential equation. Then this will be my is equal to 0 plus 2x negative 2y plus 0. Then nx will be equal to 0 plus 2x negative 2y. As what we can see, our my is already equal to our nx. Then let's proceed to the next step in solving exact differential equation, which is integrating m term in terms of x. This will be psi x dx is equal to the m term, which is 1 plus x negative 2y squared plus x raised to negative 2 plus the unknown variable, which is g of y. Then integrate, this will be dx plus y squared x raised to negative 2 plus x integration of x negative 2 plus dx plus g of y. Then we can now integrate. This will be x minus x negative 1 y squared minus x negative 1 plus our g of y. Now, this is already our general solution. Next step is get the partial derivative of the general solution in terms of y. This will be x minus x negative 2 y squared minus x negative 1 plus g of y. Then this will be 0 minus 2x, this is 1. 2x negative 1 y minus 0 plus g prime of y. To get the value of g of y, we have to equate this equation to our n term. Negative 2x negative 1y plus g prime of y is equal to the n term, which is 1 minus 2x negative 1y. Transpose negative 2xy to the right side. This will be g of y, g prime y is equal to 1 minus 2x raised to negative 1y plus 2x raised to negative 1y. This will be cancelled. Then integrate g prime of y, integration of 1. Then our g of y is equal to y. Then plug in this value of g of y into our general solution, which is x minus x negative 1 y squared minus x negative 1 plus y equals to c. Since there is a negative variable, we can rewrite this one into x minus y squared over x minus 1 over x plus y equals c. To cancel the denominator, multiply x. This will be x squared minus y squared minus 1 plus xy equals to cx. Then, this is our final answer. To furthermore understand the integrating factor, let us proceed to our second example. Let's distribute first the variable y to the equation, which will be 4xy plus y squared dx minus distribute 2 to the dy term, which will be 2x squared minus 2y dy equals 0. Then get the partial derivative of m and the partial derivative of n, which will be my is equals to 4x plus 2y. Nx will be negative 4x. Next is, as what we can see, our my is not equal to our nx, which will lead us to solve for the value of f of x. Let us try for 1 over m. Multiply to partial derivative of m minus partial derivative of n in terms of x equals to f of y. Then substitute the value. Partial derivative of m in terms of y is 4x plus 2y plus the partial derivative of n in terms of x, which is 4x, equals to f of y. Then combine like terms. 1 over y times 4x plus y. Then 8x plus 2y equals to f of y. Then factor out 2 to make the term simple. This will be y times 4x plus y times 2 times 4x plus y equal to f of y. So this will be cancelled. Multiply 2 to the 1 over y, which will be 2 over y. Then this will be our f of y. Now proceed to integrating factor. E raised to negative integration of f of y. Substitute f of y. This will be negative integration of 2 over y dy. Factor out 2. It will become e negative 2 integration of 1 over y dy. So our integrating factor will be e negative 2 ln y. Make negative 2 as an exponent, which will become e ln y raised to negative 2. This will be cancelled. Our integrating factor will be y raised to negative 2. Then distribute y raised to negative 2 to our m and n term, which is 4xy plus y squared dx minus 2x squared minus 2y dy equal to 0. So this will be 4xy raised to negative 1 plus 1 dx minus 2x squared y negative 2 minus 2y raised to negative 1 dy equal to 0. Then let us test for the exactness. My is equal to negative 4x y minus y raised to negative 2. Then our nx will be negative 4 xy raised to negative 2. So, as what we can see now, our my is already equal to our nx. Then, the equation is already an exact differential equation. So, as a next step, in exact differential equation, in solving exact differential equation, let us solve for the integration of psi x dx equal to the n term, which is 4x y raised to negative 1 plus 1 dx plus the unknown, which is g of y. So factor out the constant variable and the constant number, which is 4y raised to negative 1 integration of x dx plus integration of dx plus the g of y. So this will be 4x squared y raised to negative 1 over 2 plus x plus g of y. This will be reduced to 2x squared y raised to negative 1 plus x plus g of y. So this is our general solution. After that, get the partial derivative of m in terms of y. And now the partial derivative of the general solution in terms of y, which is 2x squared y raised to negative 1 plus x plus g of y. So this will become negative 2x squared y raised to negative 2 plus 0 plus g prime of y. Then next step is equate this one to our n term, which is negative 2x squared y raised to negative 2 plus g prime of y equals to negative 2x squared y raised to negative 2 plus 2y raised to negative 1. Transpose this one to the right side, which will be g prime of y equals to 2x squared y raised to negative 2 plus 2x squared y raised to negative 2 plus 2y raised to negative 1. This will be cancelled. Then g prime of y is equal to 2y raised to negative 1. Then let us integrate this. Our g of y will be 2 ln y. Next step is plug in this g of y to our general solution, which will be 2x squared y raised to negative 1 plus x plus 2 ln y equals to c. Then since there is a negative exponent, we can rewrite this one as 2x squared over y plus x plus 2 ln y equals to c. Multiply to y. To cancel the denominator, this will become 2x squared plus xy plus 2y ln y equal to cy. Then this will be our final answer.